have been learning division right from first standard, second standard, right? And you know that every number in division has a specific name. Let me show you an example, okay, to help you understand. Assume you are dividing 10 by say 2, okay, 10 by 2. What happens when you divide 10 by 2? What is it? Here 10, you are dividing it by 2. 5 2s are 10, okay. So the remainder is 0. Now tell me, what is the name of this? This is nothing but a quotient, right? Okay. What is the name for this? This is the divisor, okay. What about this? This is a remainder, right? And what about 10 here? 10 is the dividend. We know these things. Remember, whenever in lower classes, they used to ask you to divide 10 divided by 2. What happens? We write 5, remainder is 0. Actually, remainder is 0, we don't mention. We just say 5. If you are dividing 10 by 3, then what will you write? 3 and remainder is 1. Like this we used to write the answers, right? So, we know the name for every part here, right? Like this. Now, I am going to ask you another question. We know that 5 3s are 15. Tell me the name here. What are the names here? 15 is nothing but the product. Product of 5 and 3. You know the meaning for sum, difference, product, right? So, what is 15? Product of 5 and 3. What is the name for 5 and 3? What are 5 and 3 called? 5 and 3 are called factors of 15. Okay. So, what do we mean by factors? They are nothing. We are multiplying one number by another number to get another number. So, these two numbers which are being multiplied with each other, they are referred to as factors of the answer, right? So, here 5 and 3 are what? Factors of 15. Now, how to find factors of a given number? Let us look at this interesting example. Now, what do you see here on the board? What are these? These are nothing but some cookies, right? And arranged in a rectangular array. How many cookies are there? 12 cookies are there. Now, I want you to imagine, I want you to pack them, okay, in such a way that no cookie should be left over and every pack should have equal number of cookies, okay. No cookie should be left over and every pack should have equal number of cookies. And you know, in order to find factors of a given number, you should also be little familiar with the divisibility rules. Now, how many cookies are here? 12 cookies are here, right? And 12 is an even number or an odd number? Even number. So, it is divisible by 2. So, shall we pack them into groups of 2, like every pack has 2 cookies? Is it possible? Yes, it is possible, right? So, what happens when you do so? When you pack them into groups of 2. So, this is what happens. How many packs do you get? Every pack has say 2 cookies. 1, 2, 3, 4, 5, 6. There are 6 packs, each pack containing 2 cookies, right? So, how do you write it? Groups of 2. 2 into 6 is equal to 12. Here 2 represents what? Number of cookies in each pack. And 6 represents what? How many packs are there? Okay, but if you multiply the 2, what are you getting? You are getting the total number of cookies present here. Is there any other possibility? 12 is fine. I mean 2 is okay. Grouping into 2 is okay. And 12, what is after 2? 3. Is it possible to group them into 2? 3. Let us see. Let us take a look. Yes, it is possible. Remember, there should not be any remainder. There should not be any leftover. Okay. Yes, you can pack them into groups of 3. How many are there? 1, 2, 3, 4. Right. So, groups of 3, 3 into 4 is equal to 12. Here 3 blue color, that blue color 3 represents the number of cookies present in each pack. And 4 represents the number of packs or the number of groups, okay. And when you multiply the 2, you get the total number of cookies and there is no leftover, right. Okay, we did with 2, we did with 3. Next, let's try with 4. Is it possible to group them into 4. Let us try. Okay, see, yes, it is possible. 1, 2, 3. Each pack has how many? 4 cookies. So groups of 4, 4 into 3 is equal to 12. Now what after 4, 5? Is it possible to divide 12 by 5? I mean, divide 12 cookies into groups of 5? It's not possible, right? Because we have learned divisibility rules in lower classes, right? Numbers ending with, or in other words, numbers having 0 or 5 in the ones place or the units place, only they are divisible by 5. So if you divide these cookies by, into groups of 5, there will be leftover. 2 cookies will be leftover and strictly no leftover. Okay, so we can skip 5. Now what? 6. Is it possible? Let us see. Yes, it is possible to group them into 6. Here is 1, here is 1. There are 2 packs, right? Each pack containing what? How many? 6 cookies. So groups of 6 is equal to 6 into 2, 12. After that, 7, 8, 9, 10, 11, nothing will work. Okay, each time you try to group them, there will be some left over. And 12 finally. Yeah, you can do that, right? You can pack all of them into one pack. And there has how many? 12 cookies are there, right? So groups of 12, but only one pack will be there, one group will be there, right? And one more possibility we forgot. We can also pack them into one cookie in each pack, right? One cookie per pack means how many packs will be there? Altogether, 12 packs will be there, right? So groups of 1 into 12 is equal to 12, right? So how many groups have we seen so far? Let me list them here. Now, what connection has it got with the factors? Let me show you that also. Here, what is happening actually? What did I tell you about factors? Two numbers multiplied with each other to give you another number, right? So, what is happening here? 2 into 6, 12, 3 into 4, 12, 4 into 3, 12, 6 into 2, 12, 12 into 1, 12, 1 into 12, 12, right? And here also there should not be any remainder. Okay, so actually when I say factors, see 2 and 6 are factors of 12, okay, in general, okay, when you have two numbers A into B is equal to C, A and B are said to be factors of C, right. So let me show you here. If when you have two numbers, any two numbers that multiplies to give you, okay, A, B is equal to C means A and B are factors of C. Right. So now here what? 2 and 6 are factors of 12. That means when you divide 12 by 2, you will get what? 6. No remainder. 12 is divisible by 2. Same way, if you divide 12 by 6, you will get 2. No remainder. 0 remainder. Okay. Factors completely divide the number. Here everything. When you divide 12 by 3, you get 4. When you divide 12 by 4, you get 3. All the same. Alright. And also remember, 1 is a factor of every number. And every number is a factor of itself. That's why you are getting here 1 and 12 also as factors. And if you also carefully observe here, the red and blue numbers that are listed here. Okay. They are in different order. Same but in different order. What are these blue ones? I told you initially. Number of cookies in each pack. And what are these red ones? Number of packs, right? And but see, they are the same numbers here and there. They are kind of jumbled. Here 4 is there, there it is 4, 3, 3, 6 is here, 6 is there. You understood? So what are the factors of 12 then? The factors of 12 are 1, 2, 3, 4, 6 and 12. And also remember, the factor will never exceed the given number. Like you cannot find a factor of 12 which is greater than 12. Okay. So I hope the concept of factors is clear. Now let us look at what is common factor. So what are common factors? You know the meaning of the word common, right? Okay, let us start with this only. We just found the factors of 12, right? Let's take this and proceed. Now what are the factors of 12? 1, 2, 3, 4, 6 and 12. Right. Let us take one more number, say 16, and let us find the factors of 16 just like the way we found the factors of 12. What are the factors of 16? Look at the different groups here. How do you find it? Remember, I told you, you should be good at divisibility rules also, and you should find like which two numbers multiply to give you 16, right? Here if you see 1, 2, 4, 8, 16, here also the red ones and the blue ones, the same numbers are repeating, you take just one set. So what are the factors of 16? The factors of 16 are 1, 2, 4, 8, 16. Now take a closer look at both the list here and the list here. What do you observe? Yes, there are some common numbers, like 1 is present there, 1 is present here also, 2 is present there, 2 is here also, 4 is there, 4 is here also. Other than that, there is nothing matching. There are others are different numbers, here the others are different numbers. So we can combine these two groups, right? And what will happen if you combine these two groups? If you combine, you get this common area. This area here is part of this group also, and this area here is a part of this group also, right? So now we are going to shift all the common factors. 1, 2, 4 is here also, there also, I told you already. Now we will shift those factors, common factors, in the common area. What will happen? The factors will go and sit there. They are nothing but common factors. You understand what is common factor now? Okay, fine. Now there is one more thing I want you to observe among common factors. How many common factors are there? 3 are there. What are they? 1, 2 and 4. Which is the highest of all? Greatest number? 4, right? That's nothing but the highest common factor, HCF, as simple as that. So what do we mean by HCF? Highest common factor. So when you are given two numbers, sometimes more than two also, okay, you have to find the highest common factor. Means whatever is common among the three numbers, the factors which are common for all the three numbers or 4 numbers or 5 numbers or whatever, of that which is the highest one, that is the highest common factor, right? So I hope the concept of HCF is clear now, okay. First you should understand what are factors, and then you should understand what are common factors, and then HCF is nothing. Now HCF also has other names. In some textbooks you may find GCF, greatest common factor, instead of HCF. In some textbook you may also see the name GCD, greatest common divisor. What divisor? What is this divisor? See, like for example, 16, factors of 16, 8 and 16 are there. These are what? Factors of 16, right? So, like I told you earlier, 8 completely divides 16. That is, 16 is divisible by 8. 16 is divisible by 16. 16 is divisible by 1, 2, 4. That's why you can also call it as GCD, greatest common divisor. Okay, so I hope the concept is clear. Now let us look at some problems to understand how to find HCF of the given numbers. See, before we look at some examples on finding HCF of the given numbers, I would like to give you some important note. You may be already aware of it, but I am just saying. See, all natural numbers which are greater than 1, okay, all natural numbers greater than 1 have at least 2 factors. At least 2 factors means what? Minimum 2 factors. So if a number has exactly 2 factors, it is said to be a prime number. Otherwise, it is a composite number. You must be knowing about it already, right? Give me some examples of prime numbers. 2, 3, 5, 7, 11, 13, etc. Right? Others are composite numbers like 4, 8, 16, 12, 15, 18, etc. Right? Okay. And what do we mean by co-prime numbers? See, co-prime numbers are those numbers between which the highest common factor is 1. For example, see, you take 3. Okay, 3 and 5. These two are co-prime numbers. Why? What is the highest common factor of 3 and 5? 1. Okay, how to find HCF? I will show you anyway. Another example is 7 and 9. See, it need not be like 2 prime numbers. Okay, the HCF of 2 prime numbers is 1, therefore they are co-prime. No, it can be a combination of 1 prime and 1 composite also. 9 is composite here, 7 is prime here, but they are co-prime numbers. The highest common factor of 7 and 9 is 1, and it can be 2 composite number also. For example, 4 and 15. 4 is a composite number, 15 is another composite number, and the HCF of both numbers is 1. Therefore, they are co-prime numbers. There is another name for co-prime numbers. They are called relatively prime. Okay. So, I hope you now understand. Like, what are the points I stated here? All natural numbers greater than 1 have at least 2 factors. If they have exactly 2 factors, they are said to be prime numbers. Otherwise, they are composite numbers. And between two numbers, if the HCF is 1, they are said to be co-prime. Not just two numbers. If the numbers have HCF of 1, they are said to be co-prime numbers. Alright. So, let me quickly state the points we have learned here. All natural numbers greater than 1 have at least 2 factors. That means a minimum of 2 factors. And if they have exactly 2 factors, they are referred to as prime numbers. Otherwise, they are composite numbers. And 2 prime numbers have HCF as only 1. Okay, 1. That means they are co-prime numbers, and the other name for co-prime numbers is relatively prime. Alright, now let us get into how to find HCF of 2 numbers or 3 numbers. You can go on like that, okay. Let us take some numbers. Say we will take 24 and then we will take 42. Okay, I am taking 24 and 42. Now, there are different methods to find HCF. Now, I am going to show you prime factorization method. Okay, how to find prime factorization of 24? 24 divide by 2, it's an even number. 12 divide by 2, it is 6, again by 2, 3. Okay, so can I say 24 is equal to, how many 2's are there? 3. And how many 3's? Only 1, right? Now coming to 42. Similarly, find out 42. If you divide, what will you get? You will be getting, it's an even number. So, divisible by 2, again 3. 2 into 3 into 7, right? So, we found the prime factorization. Now, how to find the HCF? HCF of 24, 42 is equal to what? Right. Now, let us start with 2. What is this actually? 2 power 3. What is this? 2 power 1. When you are taking the highest common factor, you should take the one with the least power. Now, if you take the base 2 here, power is 1, power is 3 here. Which is the least exponent? 1, right? So, we will only take this. Okay. So, now what will happen? The HCF is equal to 2 power 1. Now, go to the next one. 3 power 1 here, 3 power 1 here. Both are same. So, take it. Then what? Here you have 7, but there you don't have 7. So, you can't take it. It has to be present. It has to be common to both the numbers. So, you can ignore 7. So, what is 2 power 1? Simply 2. What is 3 power 1? Simply 3. 2 3's are 6. Therefore, the HCF of 24 and 42 is what? 6. Okay. So, this is how we do it by prime factorization. Very easy, right? We are just finding the prime factorization of each number, and then we are comparing each and every prime factor here, and the respective, we take only the least exponent. Okay, and if that is not common, we will completely ignore, like we ignored 7 here. Now, how to do the same problem using division method, we will see. Okay, using division method, how to find the answer, how to find the HCF. Here, let us divide 42 by 24. Okay, how many 24's are there in 42? Only 1. So, what is the remainder now? 18. So, the remainder becomes a new divisor and the old divisor becomes the new dividend. Again, it is not possible to divide 24 by 18. How many 18's are there? Only 1. Okay. So, what is the remainder? 6. Now, the new remainder becomes a new divisor, old divisor becomes a new dividend. Okay. How many 6 are there in 18? 3 6 are there. Right. So, 3 6 are 18. Now, this is the divisor which gave you the remainder 0, right? You did not get a remainder 0 anywhere else. Here only you are getting. So, this is the HCF. Earlier we did the same. We got the same answer. 2 into 3 is equal to 6, right? So, now let us take 3 numbers. If you take 3 numbers, how to find LCM? Let us take, say, some big numbers we will take. 150, and then we will take 164, and then we will take 150, 164 or 162, and then we will take say 72, right? How to find the HCF of these numbers? You can find prime factorization. I told you how to find. What is 150 equal to? Let me write here and then clear, okay? 150, it's an even number. If you divide, you will get 75. If you divide, you will get 25. And then 5 5s are 25. So 150 is nothing but, how many 2s are there? 1. How many 3s? 1. How many 5? 2. So 5 square. Now coming to the next number. What is the next number? 162. Okay. When you divide this by 2, what do you get? You will be getting 81. 81 is divisible by 3. 27, again by 3, 9, again by 3, okay. So, how many 2s are here? 1. How many 3s are here? 4. So, 162 is equal to 2 into 3 power 4. Now, coming to the last one. What is it? 72. 72 when you divide by, what do you get? 36. 72 when you divide by 2, 36. Again 2, 18. Again 2, 9. Now 3. 3 3s are 9. How many 2s are there? 3 2s are there. 2 power 3. How many 3s are there? 2 3s are there. 3 power 2. That's all. Okay. Now what? How to find the HCF? We know the method, right? So HCF of 150, 162, 72 is equal to, okay. What is it? Compare. You have 2 here, 2 here, 2 power 3. Which is the least one? 2. Right. Now coming to the next one. 3 power 1, 3 power 4, 3 square. Which is the least? Again 3. Okay. Right. Coming to the next one. 5 square is present here. 5 is not present anywhere here. So ignore it. So what is 2 into 3 equal to 6. Right. So this is how you find the prime factorization of 3 numbers. Actually, I didn't want the HCF to be the same number. It just happened, okay. So now how do you find the HCF? Using division method. Now let us take 150 and 72. This is the least one and this is the next one, right? So let us begin with that. What will you get? How many 72s are there in 152? 2 72s are 144. What is the remainder here? 6. Now when you divide by 6, this remainder becomes a new divisor. The old divisor becomes the new dividend. How many 6 are there in 72? 12 6 are there. Okay. I am directly doing, you can do one by one also. 12 6 are 72. Okay, you are getting remainder 0. Therefore, HCF is 6. No, we have one more number left. We should see whether this works there also, right? So now take this 6 because it gave you remainder 0. So take this 6 and go and take the missed number, like the one which we did not consider so far. So divide that number by 6. What do we get? 2 6 are 12. What is the remainder? 4. What is the other number? Bring it down. 42. 7 6 are 42. Now you are getting 0. Therefore, it is HCF. Okay. When you are dividing, you take this 6 which gave you 0 here. You combine it with the other one. You divide this one by this 6. Okay. If you are getting the remainder here also as 0 after dividing by 6, then HCF is 6. Otherwise, you have to proceed like this. Okay. Until you get 0. Okay. The divisor which gives you 0 is the HCF. Therefore, HCF in this case also equal to 6, just like the prime factorization method. Okay. So, I hope these things are clear. I mean, these examples are clear. Now, let us start with multiples. Will you believe me if I say multiples need no introduction because you already know multiples. But maybe you don't know that they are multiples. What I am talking about is, see, right from class 1, nowadays even before that, you are learning something under mathematics in school. What is it? Times table, right? Take a look. What is this? This is what you learn when you are children, when you go to school, right? Under maths. Along with addition, subtraction, we also every day learn 2 table, 3 table, 4 table, right? So now what is happening here? If you observe, let me write it here. Now what is happening is we are multiplying. What is 2 table? 2 times 1 is equal to 2. 2 times 2 is equal to 4. 2 times 3 is equal to 6. 2 times 4 is equal to 8, and so on. You can go on forever, right? Here 2 is a multiple of 2. 4 is a multiple of 2. 6 is a multiple of 2. 8 is a multiple of 2. All the answers that you are getting after the multiplication are all multiples of that respective table. This is 2 table. So these are multiples of 2. If you write 3 table, 3 ones are 3, 3 twos are 6, 3 threes are 9. The 3, 6, 9, etc. are nothing but multiples of 3. Okay, that's it. You are multiplying 2 with 1, 2, 3, 4, you get multiple. If I ask you to find the multiples of 7, tell me some first 5 multiples of 7. Very simple. All you need to do is 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are like that. You have to do up to 5, 7 fives are 35. You understood? If anyone is asking you to tell the multiples, first 5 multiples, 6 multiples of a given number, simply tell them the multiplication table. Okay, so I hope you now understand what are multiples. Let us take the same example that we saw under, the cookies example that we saw under factors. Like these are the different groups we got, right? Like I told you earlier, now 12 is the product you are getting in each case. So what do you think? Here 12 is a multiple of 2, I can say, right? 12 is a multiple of 6, 12 is a multiple of 3, 12 is a multiple of 4, right? So in general, I gave you the similar example there also. If you have A into C, A into B is equal to C, okay? A into B is equal to C, AB are factors of C, and C is a multiple of B as well as A. C is a multiple of B, C is a multiple of A, you can say, okay? Fine, I hope now you understand what is meant by multiples and how you can find multiples of a given number. Now let us look at what are common multiples. Just like we learned about common factors, let's use the same method, okay? Let us take some multiples of 2, okay? Some multiples of 2, you know, very easy this is, right? 2 table, like 2, 4, 6, 8, and the list grows forever, goes on. See, factors is not like that. Factors is limited number you get. But multiples, when I say multiples of 2, there is no end, you can go on forever. That's why I have put the dot, 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 okay. Now let us take another number and find its multiples. Multiples of 3. 3 ones are 3, 3 twos are 6, all those 3, 6, 9, 12, 15, 18, 21, etc. Right? This list is also very huge. And what do you observe here also? If you carefully observe, some numbers are there and here also, right? What are they? I have simply highlighted some of them like 6, 12, 18 and 24, right? Now, since that group and this group has something in common, let's unite the two. So, what will happen? So, when you unite the two, this section here is common for this set also, and this section here is common for this set also, right? This section here is part of that and as well as part of this. So, that represents what? Common multiples. So, all the common multiples should be sitting in that place, right? See, I have removed them from here and put that here, right? These are nothing but common multiples. Now, if you take a closer look, which is the smallest? It is not possible to find the biggest, greatest multiple because it goes on forever, infinity. We can't find it, right? So, but you can find the least common multiple. What do you think is the least common multiple here? 6, right? So, 6 is nothing but the LCM. Some people call it lowest common multiple or some people say least common multiple. Both of them are